In this video, we will find the arc length function for a curve. So remember what the formula is in general. We usually call it S for the arc length as a function of t. And it's given by this. It's the integral from the starting time, in this example, that's -3, up to t, the same t that's the input to the function. And what you integrate is the speed of the curve, that is, the norm of the velocity vector, or the derivative vector of the curve. And since I'm already using t as the bound on the integral, I don't want to use t here as the variable inside the integral, so I'll use some different letter like u. So again, the arc length is the integral of the speed, or the integral of the norm of the derivative. Okay, so let's figure out what this is in this specific case. So first, what's r prime? Since we're not doing it inside an integral, it's safe to use t here. Let's see, the derivative is -2 sine of 2t, 2 cosine of 2t, and 2. And there's a 2 in each slot, which we could factor out if we really wanted to. Like so. And we need to take the norm of this. So this 2 just comes out. And we square everything and add it up. But, of course, sine squared plus cosine squared is 1. So this becomes really simple. It just becomes square root of 2 in there. So actually the derivative is constant. It doesn't depend on t, it's just always equal to 2 times the square root of 2. So finally, go back to the formula we had at the top. It's the integral from -3 up to t of the norm of the derivative, which we just found was the constant quantity 2 root 2. And so this integral is simply 2 root 2 times t minus -3, or t plus 3. And there we have it.